Thank you for coming at a 5 p.m. session on day 2. It's an amazing crowd. We were expecting 5 people along with my parents. So our session is implementing microservices tracing with Spring Cloud and Zipkin. Who am I? My name is Reshmi Krishna. I'm a platform architect with Plvotal. I mostly work with customers from financial services and help them transform the way they build software. Previously, before working at Plvotal, I used to work on Wall Street. I was part of an investment bank and also a startup on Wall Street. I'm also a member of Women in Tech, and I'm really I do look like an engineer, so I do really go by whatever Cornelia said in her keynote. My Twitter handle is right up there. I also host the Cloud Native New York meetup, so if you're ever interested in speaking or attending, if you're ever in the area, do hit me up.
Hi, my name is Marcin Grzejszczak. I'm having a very difficult name to pronounce, and also I'm working as a part of the Spring Cloud team. I'm working mostly on the Spring Cloud Sleuth stuff and Spring Cloud Contract, so come to my talk tomorrow to learn more about Spring Cloud Contract. I'm an automation freak, so all of the code that you're going to see, you can actually clone from GitHub and run with a single bash script. My Twitter handle is @Grzejszczak, but it's easier to go to my blog, tomuchcoding.com, and find my Twitter handle there. So what are we going to talk today about? So we're going to start with showing how we can correlate logs with Spring Cloud Sleuth and why we should do that. Then we're going to talk how we can visual latency with Spring Cloud Sleuth and Zipkin. Next, we will show, actually Reshmi is going to show that, how we can leverage the Plvotal Foundry to deploy and integrate apps with Spring Cloud Services and Zipkin. Next, we'll show how to integrate Spring Cloud Sleuth and Zipkin in an existing application. And finally, we're going to show how to use PCF metrics and Zipkin to investigate certain issues. OK, so let's get it started. Let's imagine that we have an ordinary system. So service 1 is calling service 2, and service 2 is calling service 3 and service 4. I'm pretty sure that most of your production systems look like this. So we're going to focus on this example and play with this until the end of my part. So actually, everything is awesome. By the way, there's going to be quite a few very funny things in the presentation and very good animations. So this is one of them. So there is a client who's playing around with an application that we wrote. So he's clicking around, and he gets a kitten. So everything is fine. Everything is awesome. But actually, it's really cool until it's not, right? So the user is, again, clicking around, and he gets a 500. So actually, he's very not happy. So a table flip occurs. It has to happen. And because he paid for an application that was supposed to work, right? So he's calling the customer service or filing issues, and he's right to do so. So it's our time as developers to wear our suits like this and jump into this gigantic pile of code that has been written over a century. And we have to debug an issue. We have to find the reason for this exception that happened, right? So actually, believe it or not, but I lied to you, because your system doesn't look like this. It looks more like this. So the service 1 is deployed in 5 instances on 5 different servers. The same is with service 2, 3, and 4. Right? So you have plenty of servers, plenty of instances. So now the main question is, on which server and instance was the exception from? So how can we answer that question? The answer to that is distributed tracing. Who attended Adrian's presentation? OK, I think most people. So I will not go into details what those terms are. Maybe I will just recap it for a minute. So those 4 terms will help us answer the question, which of those services blew up. So we have a span. Span is an operation that is bounded in time. So for example, an RPC call is a span. So it took some time. It had its beginning and the end. Trace is a set of spans. So if, for example, you're doing for example, library, so to say, and this library has an endpoint that you can shoot and find the list of available books. So if you need to hop between 5 services to get that list of books, then you'll get 5 spans, but 1 trace. So all the spans share a single trace ID. and form a single trace. Logs are things that happened in time. So let's say once I finish my part, I will be able to log an event that at this particular time, I have finished my presentation, right? So this is a log. And a tag is a key-value pair. So since I'm giving quite a few talks, in order for me not to forget at which conference I did a talk, I can put a key-value pair, like conference equals SpringOne. So a tag is a key-value pair. Why is it useful? We're going to show it later on in the demo. Now, is context propagation simple? So in order to do distributed tracing, you have to pass tracing information between different things, like processes, different threads. So is it that simple? So the first question is actually why my slide doesn't look as it should. And the second one is how do you pass tracing information, for example, trace ID between different libraries, thread pools, when you're doing asynchronous communication, etc., etc. So actually, when we were building Spring Cloud Sleuth, this is how we look like, because there are plenty of edge cases that you have to take into consideration when doing instrumentation of a library. So that actually is not that simple. That's why we built Spring Cloud Sleuth. So it's like transparent for you. And what we do is that we take care of passing or tracing information between threads, libraries, contexts for example, Hystrix, RxJava, when you're using REST template. For Feign, messaging with Spring integration, Zuul, there's quite a few of those. And actually, if you don't do anything unexpected, everything should work fine. So in order to know what is like expected, check out the docs and follow those guidelines over there. If you do things properly, the context, like the tracing information gets propagated throughout the whole system, and you can profit from log correlation. So let us go back to our main problem. We had a lot of instances, a lot of servers, and one of the instances has blown. I mean, there was an exception. So what we can do is that instead of SSHing to every single machine, finding the logs, grepping for error, we can do something more intelligent, which is aggregating the logs in a single place. So with Cloud Foundry, you have Logaggregator, where all the logs from different instances are streaming to one single place. Reshmi is going to show that later on in her part of the presentation. I'm going to focus on another approach. So you can use a process called log/forwarder. Right now, I think it's called FileBeat, which harvests the logs from the provided location and sends them to a given place. And that place is the elk stack. So actually, log/forwarder, the name is pretty good because it forwards the logs to logstash. And from logstash, you can parse the logs, put them into Elasticsearch, and then use Kibana to search over those logs. We're going to play with that in a second. So how can you profit from Spring Cloud Sleuth? With Maven, you add the Brixton SR4 bomb, so the most recent one, Spring Cloud dependencies, and you provide the dependency to Spring Cloud Starter Sleuth. If you do that, then out of the box, you have log correlation. So what we're going to play with right now is the following situation. Let's say we have a service 1 that has an endpoint read timeout. As you can imagine, what will happen eventually is a read timeout. So service 1 is going to call service 2. And right now, this is the part with the animation. Service 2 will call another service which doesn't exist. Cool, isn't it? And what happens is that exception is propagated because there is no such service present. OK, so time for the demo. So what we're going to do is to shoot a request at localhost 8081 read timeout. So what happens here is a 500. Right? Okay, you see that? Yeah. So let's go to Kibana. So this is Kibana. What we can see here is those green bars represent some logs that have been harvested in time. What's crucial is that before we focus on this one, let's take a look at the logs. So what Sleuth does is that it gives you a unified way of logging. So if we check out here, we can see that Spring Cloud Sleuth prepares for you a very nice logging pattern, because often people forget about some stuff. So let's go through the logs. Let's say for over here. So we have a timestamp, we have severity, application name, trace ID, span ID. This true means whether the span is exportable to Zipkin or not. We're going to talk about this later. This is the process ID. At some point, I was curious what those 3 bars represent, but actually these are just 3 bars. Like to separate one part of the log from another. Here you have a very, very important thing, which is the thread name. So when you're doing parallel processing, like calculating stuff in parallel, and you don't provide the thread name, how on earth can you know like which log is related to which part of your code? So this is crucial. So we give it this for free. You can take it. Here you can see the name of the class and the text. OK, so let's go back to Kibana. So what we see here is a couple of logs. So what we can do is search for those logs that resulted in an error. So we see quite a few. And let's say that we received an information from the customer service that an exception was thrown around, let's say, 5 p.m. So what we can do is to use this trace ID to find the proper log. So we can do like this. And what we see here is that for the given trace ID, we get all the logs that were related to a single, let's say, business operation. In our case, it was a request that came in and resulted in an exception. So here we have just 2 services that take part in this operation. But imagine having like 50 or 100 microservices that take part in one single business operation. So using log aggregation, you can have all the logs in a single place. And by searching via a trace ID, you can find all the services that took part in this operation. Yeah? So the question is whether isn't it easier to search via a string instead of a trace ID? Yeah, I mean, if you have proper exception handling and let's say the user receives some information that you can search over, maybe it's right. In this case, I want to focus on showing that with let's say log aggregation, by knowing the trace ID, regardless of how you find the proper log, you can see the whole history of logging for the whole system, right? Well, that's a very good question. So let's search via this trace ID again, trace. And here you can see a lot of logs because I was searching via. I didn't pick proper severity in terms of the logs that I want to present here. So what I'm going to do is I'm going to copy. Oh, nice. Whoa. OK. So right now, I'm going to order all the requests in time, so in a chronological fashion. And what we can see here is like that service 1 was calling a missing service, and an exception read timeout occurred while trying to send the request. So in that way, we have ordered the requests in time. We found the proper log from our distributed system. In that case, like it's not really awesome because we have only 2 services, but imagine the case where you would have 100. In that way, you can, like in a chronological order, see all the calls, all the logs, and find the reason for the exception. So what we support also in Spring Cloud Sleuth documentation is a guide how you can set up your logback in order to log in a JSON format. That way, you don't have to cut with regular expressions in Logstash. So check out the documentation on how to do that. OK, so that was really easy. Log correlation with Spring Cloud Sleuth. So that is the screenshot if the demo gods weren't happy with myself. So yeah, I've shown you that. OK, so that was really simple. So Sleuth gives you log correlation, the tracing information is passed, but you had like a 0-1 situation. An exception was thrown, the user saw that, he's furious, and we managed to find the reason for the exception. But what about the case where the system is slow? So we have, again, the user. He clicks around. He gets angry. Only then does he receive the kitten, right? So this is a more problematic case, because in the logs, you will not see like anything suspicious, right? Because the system is working fine, but it's slow. One of those services is slow. And now the question is, which one is slow? How we can measure that? And how can we visualize latency in a distributed system? So the answer to that is Zipkin. So how does Zipkin actually work? So we have our applications. They are using Spring Cloud, obviously, and Spring Cloud Sleuth. And thanks to that you're using this technology, spans are sent to things called collectors. So Zipkin has collectors which listen to the spans, either via HTTP or Spring Cloud Stream. And the collectors store those spans in a database. So if you go to the Zipkin UI, as Adrian shown, you click around. So UI queries for trace information via something called an API. And this API is querying the database. So how do you integrate Spring Cloud Sleuth and Zipkin? So the most important thing is that we take care of passing tracing information between threads, libraries, and contexts. Without that, if you don't do proper instrumentation, I mean, you won't achieve much. The next thing is that when you close a span, so span has been finished, this bounded operation has been finished, we will send this span to Zipkin for you. Depending on the provided dependency, either we're going to send it via HTTP automatically, or via Spring Cloud Stream, for example, via Rabbit. And this collector that I told you about can be a Spring Boot app. So it's enough that you provide the Spring Cloud Sleuth Zipkin stream dependency, you annotate your class, and you're ready to go. And if you provide the dependency to the Zipkin UI, you can also have the UI. So how can you add it? Of course, you add the Maven BOM, so Brixton SR4. And you provide the dependency to Spring Cloud Starter Zipkin in order to have the HTTP-based communication. Now hold it. The thing you should ask is, hey, if I have a billion services that emit gazillion of spans, won't I kill Zipkin? Right? And that's a very good question. And even if you don't kill Zipkin, you can run out of disk space because you have to store this information. So if you don't have like a gigantic traffic, you won't have a problem. But if you do have gigantic traffic, you have to think about this. So the question is to trace or not to trace. And now the answer is sampling. So by default, in Spring Cloud Sleuth, we send to Zipkin only 10% of requests, so to speak. So every 10th trace will be sent to Zipkin. You can change that by providing the value of the property Spring Sleuth sampler percentage. If you provide 10, then all of the spans will be sent. Like, it's awesome for the demo, for example. And it's also awesome to remind that because sometimes people say that Zipkin is like Spring Cloud Sleuth doesn't work because only the 10th request ends up in Zipkin. So that's deliberate. You can also register a custom sampler implementation if you want to do something else rather than percentage-based sampling. OK, so now we're going to do the demo. So this is the service, that like the situation that I talked about. So service 1 is calling service 2. 2 is calling 3 and 4. And now we're going to create a awesome branded SpringOne service specific for this conference. Yeah, time for the demo. So we're going to play around with Sleuth and do some awesome stuff. So the first thing you should do, obviously, is to go to start.spring.io. So as Josh Long says, if your children are crying and you feel miserable, go to start.spring.io, create a project, you're going to feel better. So what I'm going to do is I'm going to pick some dependencies because they give them away for free. So I picked web, Feign, Hystrix, Zipkin client, actuator, and the artifact is going to be SpringOne. I'm hardcore, so I'm going to use snapshots. So I'm going to generate the project. Now, is there the internet? Of course not, but I felt it's going to end like this, so I've already downloaded it before. So let's go to downloads. SpringOne backup. So let's go to repo presentations. And let's extract this. And let's open the IDE and open the project. OK, don't look at this. It's confidential. Come on, where is it? SpringOne. Oh, the demo gods. Dear Mr. IntelliJ, don't do it to me. OK, open. Of course, it worked on my machine before. So, of course it is. OK. Like every professional computer scientist, I had to open it, close it and open it again. OK, so resolving dependencies. Maybe it will resolve something. So do you have any questions in the meantime, since it's resolving dependencies and I have internet problems?
I have a question.
Yeah, go ahead.
Just to clarify, so we still have Kibana and log stash with Sleuth, and so we can still get all the logs with the trace and spans. That's not getting lost. However, in order to check latency, we're getting 10% of those being sent to Zipkin.
Exactly.
So we still have those there, but we also have Zipkin with 10% to see how we're doing.
Yes. So the question was, if we have sampling of 10% of requests, the question was whether we have 100% of log correlation. That's exactly the case, but only 10% are sent to Zipkin. OK, so let's write some code. We have everything running. So for those who don't know start.spring.io, the project has been generated. We have snapshot versions. Actuator is there, Feign, Histrix, Zipkin, web, everything is there. So what we're going to do is a SpringOne controller. SpringOne controller. I have some notes here if I forget about something. OK, so we're going to do a public class. Why not? REST controller. We're going to call some stuff via REST template. So we have to do the construction injection. Who is doing field injection? Or don't even know? Raise your hand. So since we're using Spring Boot 1.4, we don't have to auto-wire on the constructor because it's going to be done for us. And now we're going to have a method called SpringOne, request mapping, and SpringOne. So what we're going to do is maybe not Spring, but string will be better, response. And now, as like everybody knows, with microservices, the best thing, or actually the worst thing you can do, is hard code the URL import. And I'm precisely going to do that because I need to simplify the demo. So I'm doing localhost 8081/start. And I'm going to return this string, not copy value of, but class. And what I'm going to return is SpringOne plus response. OK, simple stuff. Now in SpringOne application, I'm going to register the REST template bean. Return new REST template. And now we have to name somehow our application. So Spring application name is going to be SpringOne. Server port is going to be 9966. Why not? And now I never remember the property. OK, so Spring Sleuth sample percentage 10. So we want to sample all the requests. OK, so now if I didn't do anything stupid, it should work. So let's try to run it. So we'll have a SpringOne application running. We'll have one endpoint called SpringOne. If we should add a request at that endpoint, what should happen is we're going to call service1. So the app is up and running. You can see that since we have Sleuth, we already have the predefined logging format. Here you can see the name of the application. And now time to make a call. So SpringOne. OK. Yay, something is even working. So What happened is that service 1 called service 2, 2 called 3 and 4, and all the responses got merged back and presented to the user. So now if we go to the Zipkin, to our Zipkin, what we can see is that we have a new trace. Nice. So we can see here is that our trace took 2 seconds to complete. Why is it that slow? Because I put a lot of sleeps in the different services. Altogether, there is more than 1 second of sleeps. What we can see here is a very interesting thing from like instrumentation perspective. So SpringOne service is going to call service 1. Actually, if we go to the dependencies, we can see exactly the graph of calls, right? So SpringOne is calling service 1, and etc. So if we go back to our trace and check the first client-side span, we're going to see the whole RPC situation, right? So first we have client sent after relative time of 34 milliseconds, then server received, server sent, client received. You have the default span tags over here, so HTTP host, method, path, and URL, and the name of the endpoint that we're shooting on the server side. And now if we go to the server side, you can see that we have the method, oh, sorry, not this one. So, yeah, so the first, in the service 1, the name of the method that we shoot on the controller side is start, and the controller is present in the application class. So if we check the same here, the same thing here on the in the SpringOne application, you can see that the class that processed the request was SpringOne controller, and the method SpringOne. So this is really valuable because you can go directly to the code and see which method was responsible for processing that request. Okay, so that's very simple. Let's do something more interesting. So we're going to create a custom span. So what we're going to do is do something very important. So let's do that. In order to do something very important, we have to create a span. So in order to create a span, we have to inject something called a tracer. Tracer is an interface from Sleuth that allows you to create spans. So we do tracer, create span. Let's say SpringOne span. Why not? So we have a span. And the most important thing is to always remember when you create a span, you have to close it. So in the finally block, let's do close on the span. It was like a magical moment, right? So thank you. Yeah, I know, it's awesome. So the thing that we're going to do right now is we're going to create a tag. So since, let's say I'm giving quite a few talks, I want to find the trace that was present for this particular conference. So conference is SpringOne. So this is a very simple way of creating a tag, appending a tag to the current span. So like you can agree that Spring Boot is very simple, right? So it takes about 1 second to learn Spring Boot, no more. So we're going to log event that after 1 second, we learned, this is British like typing, right? Learned with a T. So let's leave it like this. So 1 second and we learned Spring Boot. You can also agree, sorry, Spring Boot. You can also agree that the same thing applies to Spring Cloud. So here we have 2 events that have been logged on a span. Okay, so right now, let's say we're going to do SpringOne span. So if I didn't do anything wrong, what we would expect is to have a very similar trace with an additional span, which takes about 2 seconds to run. So the app is running. Let's close this one, and let's shoot a request here. So we have SpringOne span. Very good. So let's check Zipkin. Let's find some traces. Newest first. Yeah. Let's click it. Yeah. So here is our custom created span, SpringOne span. Those white dots are those special events that we created. So learn Spring Boot and learn Spring Cloud. If we click it, we're going to see that it took 2 seconds for this custom span of ours to finish. And we have 2 events, learn Spring Boot, Spring Cloud. And here we have conference SpringOne. So now the cool thing is that if I go to Zipkin here and type in conference SpringOne, I'm going to filter out all the other traces that I had, and I find this particular one related to a SpringOne conference. So now, let's say you're joining this project, you have no idea what's going on. You take a look at this graph and say, what is wrong here? Why is this bar so wide? Why not move this to the left? OK, let's do it. So what we're going to do is obviously use an executor service, because we're going to do some parallel computing. Why not? So we're going to do executor service. Let's call it service, executors, and new cached thread pool, for instance. The next thing we're going to do is we're going to create a, well, let's say, public static class SpringOne runnable that implements a runnable. We're going to use a super cool annotation called span name, which actually tells exactly what it's going to do. So it's going to wrap this runnable in a span with the name that we provided in this annotation. So let's name it SpringOne runnable, maybe. Why not? And this logic we're going to put inside our code here. We need a tracer, so let's inject it, private final tracer. OK, do something very important. The last thing that we're going to do is that we're not going to create a custom span over here. We're going to reuse the one that's going to be created for us. So with tracer, in order to get the current span, you can use the method getCurrentSpan. And the finally block, we don't want to close it. OK, so we have our custom SpringOne runnable. And now what we're going to do is call our service and do a submit. Now, what we need to do is to wrap our runnable in a trace representation, so a trace runnable. It takes some parameters, so I'm going to pass it. Tracer, span namer. Span namer also has a nice name, because what it does, it's naming spans. OK, and now our SpringOne runnable, and that's it. So we're going to use executor service in order to submit a runnable. We have our future, and we will block over here. Obviously, this is Java, so we have a lot of exceptions to throw. And let's do SpringOne runnable. So basically, all the long waiting tasks we have put in a runnable, and we're going to execute that runnable and block after we have received the response from our slow services. So let's run it. So what we're going to expect is to have a better graph, like all this part should go to the left. So let's check it out. SpringOne runnable, OK, changed. Let's go to Zipkin. OK, let's find the newest first. Now it looks much, much better. So since we did some stuff like behind the scenes, the tracing information has been properly propagated between different threads, and our stuff that was like the REST call, sorry, was done like in a much faster way. Like we didn't explicitly block for the first SpringOne runnable operation. We waited until we have received the response from all the 4 services. What you can hear is that, see here is that SpringOne runnable name was provided to the span with this annotation. So the thing you can say is that never in my life, ever, I have created a custom class for a runnable. And maybe you're right. So let's do something maybe more interesting. So what we're going to do here is we're going to create a new runnable and put all that code that we had here inside that runnable. Because most likely you're using anonymous like implementation of runnable. So we put it here. So the question is, how can we name this span? Like, I mean, you cannot put an annotation on an anonymous class. So what we're going to do here, I know that it's not looking like really pretty, but whatever you put in the string method is going to be applied as a span name. So we're going to do poor man's runnable. And we're going to run the whole code again. So what we would assume to happen right now is exactly the same thing. The name of the span will change into poor man's runnable. So this is the way we decided is going to be the easiest to do instrumentation of those runnables that you're creating via the new keyword. OK, let's check Zipkin again. Newest first. Hey, we have exactly the same thing, and we have poor man's runnable over here. OK, but you might say that you don't like using runnables. Let's use something cooler. So since all developers should be lazy, they should delegate work to, for example, a worker. So let's create a component. We're going to inject the tracer here. And this awesome method, do something very important, will end up in the worker. But we're going to make it public and async. Oh, and even let's do it like this, that we're going to return the future. The future of void sounds like the name of a movie. OK, and let's return a null. Why not? We don't care about the result. OK, so here let's enable async. And let's fix our code. The private final SpringOne worker. There we go. And let's remove all of this code. And let's call it like this. Most likely it should work. So let's do it like this. So right now we're delegating work to a class that has a method that is annotated with async. Let's call it. There we go. We're going to shoot it again. SpringOne async. Cool. And now we'll see if I did everything right. Oof, it's working. So here we can see the async span that has been created automatically by Sleuth. And then a new span, which is called do something very important, because it analyzed which method will be used. We can click it, and we can see that in a class SpringOne worker, there is a method called do something very important that did this asynchronous communication. And all the annotations and tags have been put over there. So the last thing that I want to show you is Hystrix. So what we can do, let's say we're going to do something else over here. Let's say that we're going to have another method in the worker, public string call service or service1. We're going to annotate it with Hystrix command. Let's say command key is going to be calling service1. Okay, and here we're going to use that REST template of ours, private final REST template. And let's copy paste. Why not? Okay. Oh, my IntelliJ. Okay, and SpringOne Hystrix response. Okay. So right now, let's say what we're going to do is we're going to do it like this, call service. Of course, I always forget to do enable Hystrix, and then nothing works. So who thinks that we're going to, let's say the status code of the whole trace is going to be 200? Raise your hand. Who thinks that we're going to call this? The only thing I did, I wrapped the call to service1 in a Hystrix command. Who thinks there's going to be 200? Nobody? OK, quite a few people. Who thinks there's going to be an exception? Why? No, I'm going to answer why. Very good, very good. So what's going to happen is, that's why I explicitly said at the beginning that the sleeps are over a second. Since we're wrapping it in a hystrix command, it's going to time out. But the cool thing is how you're going to see that in Zipkin. If I had any prizes, I would give you one, but I don't. So I can shake your hand. So let's call it. Yes, calling service 1 timed out. So if we go to Zipkin, the awesome thing is, if we go here, we can see all the trace. Why is it so? Because there was processing done like further on in service 1, 2, 3, and 4. And after a second, hystrix cut the communication. So this is really awesome because even though if you click here, you're going to see that status code is 500, you can still see what happened under the hood after we have received the bad result. And the last thing is if I click here, so the question was, how is Zipkin running, right? So I had it, I started it before like giving this talk. So it's basically a Java app, like Java job. No. I started it manually, and I added, Sleuth integration to all of the apps. So that's why we got it. OK, so my time is up. So this was the first part of the talk. And now off to Reshmi.
So thank you, Marcin. I think that was amazing. What do you guys think? All right. For the second part of my talk, I'll be talking about how to integrate these amazing technologies into a Java and Spring application. And then I'll also be showing a demo of how these applications can be deployed onto Cloud Foundry, and we can take advantages of the Spring Cloud services that's running on as part of the services marketplace in Cloud Foundry. And we'll be investigating issues using PCF metrics and Zipkin. So before I move on, how many people here already know about Cloud Foundry or have seen a demo? OK, I guess that's over 100, like 100%, not over, sorry. All right, so I'm not going to talk a lot about it. Just briefly, it's a cloud-native platform which can be installed on top of any of your virtualized infrastructure. It was developed for both developers and operators. It provides you with a container runtime. And there's also a lot of variety of marketplace services that you can take advantage of. And for operators, it gives you the visibility and controls to see the applications running, and a lot of RBAC controls that also comes with it. So another great thing that comes with Cloud Foundry is a marketplace. So as part of the marketplace services, we have Spring Cloud Services tile. So once you get that tile, the thing that you get with it is these three things: config server, service registry, and circuit breaker. And all you have to do is implement the client version, the client side on your application, and you can just bind it to these different services. Moving forward, the existing app that we'll be looking at is a trading application that was originally built by members of the platform architecture team. I see Corby sitting back there. He has contributed to the app as well. So the application has 4 different microservices. The first one is the web UI, just a web interface. The second is the portfolio service that gives you portfolio information about the trader. The third is the code service that gives you code information, and the account services. And in the back end, it connects to 2 different databases and connects to Spring Cloud services. Now, for me to integrate that application with Sleuth Stream and Zipkin, I needed to do 3 things. The first thing I did was I put the Sleuth Stream dependencies in my build.gradle, and we will see the code right after this slide. I also bound it to RabbitMQ. And the third thing I did was, since I was going to use Pivotal's Cloud Foundry, I deployed Zipkin as a single application. So it had all these different components, and it was deployed onto Cloud Foundry. And all I had to do after that was connect it to the same RabbitMQ instance. All right, so now let's go to the code and look at some demos. So I've been having some internet issues using this MiFi. So thank you, Fred, for lending me his MiFi. OK. All right, so this is the application you see here. And you see in one of the microservices in the build.gradle, I have these two dependencies that I added, sleuth stream and binder rabbit. I'm using 1.3. I'm not as cool as Marcin, not using snapshots. So 1.3 using Brixton SR3. Brixton SR4 is out. You can use that as well with these additional capabilities that Marcin just demoed. The second thing I did was, as Marcin indicated, I want to sample 100% of the application. So I had to set the sleuth sample percentage in my configs, which is deployed as part of the config server of Spring Cloud Services. And then another thing I did was I implemented some custom traces and spans that you will see from my demo. So we'll be coming back to the code and looking at those. Let's go back to my Chrome. All right. So the thing you see here is Plvotal's Apps Manager. So Apps Manager is a user interface where you see all your applications. Those are deployed. You see I've deployed my 4 different microservices, and I've also deployed Zipkin as an application. Now drilling down into one of the microservices, the quotes microservices. So no, not right now. So that's on our roadmap. Oh, sorry. So the question was, can you deploy Zipkin as a tile? So the answer is not right now. It's on the roadmap. So for the code services, I bound it to these different circuit breaker, discovery service, config server, also using the RabbitMQ instance. And for Zipkin, as Adrian was mentioning, if you're new, so this is all the new technology. So I'm using MySQL as DB store, and I'm using the RabbitMQ, same instance as my code service and other microservices. Now, another thing, now you see the circuit breaker dashboard that is deployed. How many people here already know about circuit breakers? And all right, so all of you. That's great. I'm going to go. And another thing you see is the PCF metrics. So PCF metrics is a product that you can get as part of Cloud Foundry. And what you see here is different metrics coming out of your platform. And all your logs are aggregated. So as Marcin was mentioning, the component called Logaggregator. So when you deploy your applications in Cloud Foundry, all your logs from different instances get aggregated. And this is what you're seeing. It's very hard to read right now, but when we demo, we are going to search for certain things, and you're going to see. So let's start with the demo. OK, let me move this here. So I'm just going to log in. My user is called Wolf of Wall Street. OK, so you see that I've already made some trades. So who here looks at logs when everything is working? Wow, no one. That's great. That's what I was expecting. Marcin raised his hand when I asked him, so he's an exception. So let's look at 2 scenarios. The first one is, let's look at something that I know it's not going to work because it's a demo. So I'm going to type some symbol, of course, that doesn't exist. I'm going to be an impatient user. So if I click this enough time, I should see my circuit getting opened. So you see here, my circuit, the get company's circuits has been opened. So you see all the traffic that came in. the circuit was open. So that's great. Now you know, okay, something is going wrong. My circuit breaker, my circuit has been opened. How do I debug this scenario? I have some tools in my hands. So the first thing I'm going to do is I'm going to go to PCF metrics. I'm actually going to go to the codes application. And now I want to see if there were any errors in my logs. So let's see. OK, so this is 551.02. You see here, I have selected all the logs from different components in the Cloud Foundry. You can actually just uncheck these, and you can only see the app logs. So now one more thing is on, help, OK. So now I only see the app logs. And you see I still have the error from the applications that's coming out. And it says something went wrong. That's a great log message. OK, so something went wrong. What went wrong? I know it's coming from code v1 controller class. So since I have Zipkin, I have the power in my hands to look at all the requests that came in and gave me this error. So let's go back to Zipkin. I don't like the resolution. I'm going to, OK. Can you guys see in the back? OK, all right. So I'm going to look at, you see I have the 4 different microservices. I'm going to look at code service. I'm going to look at the specific traces for XYZ symbol. I'm going to find the newest trace. OK, it's 2 minutes. 2 minutes ago, looks like what I did. OK, so now you see all these different traces. And now if I do an expand all, you see right off the hand, this looks something weird, like a 20 microsecond. So let me click here. And you see annotation says company not found event. That means I have typed in something in my code that gave me the error because of the white dot here that Marcin was talking about before. And this came from this get companies. So if I click here, you will see the code v1 controller method get companies through this error. So let's go back to my IntelliJ. Conveniently, we are at that location because it's a demo. So you see in this method get companies, I have opened the code v1 controller. I have a fallback method get backup company. Looks like when my circuit was open, this get backup company was called. And this is exactly what I've seen. I have seen the lookup company info in my span. I saw the event company not found. So that's great. So I know exactly, I can pinpoint exactly where the error is in my code. And from here, I can go to fix it. Now, another thing, if we go back, I want to see, so let's click here. This is the Great Dependency tab of Zipkin. So I'm going to look at some recent transactions. All right, so I'm looking at 4 minutes of transactions. And what you see here is, let me zoom in. So what you see here is the variety of relations of different microservices. So that's not great. OK, so you see a couple of dark lines and light lines. So the darker the line means web services called portfolio services by that many number of times. So if I click here on portfolio service, if I click on web service, it says the number of calls made were 35. So the line is much, much darker rather than this, the account service that was used by web services, the number of calls was only 1. So you see now here, I only have 4 microservices for my demo, but like in real life, you will probably have a lot of more of these microservices. So I believe this is a very useful tool that you can use to see what exactly happened, which microservices called which microservices, right, in the given time frame. Another thing, So Zipkin, as Marcin was already showing, gives me the ability to search for exactly if I have the key value tags already in my code, which I do for symbol, each symbol. You will see if I query this, bless you, you will see all the traces and spans that corresponds to this symbol. Now, going back to your business scenario, you can add different key value pairs for your different things like volume of the trades that you want to look at and all of these different things. So this is really useful as well. Now, yeah?
Can I do something, not just a quality testing, but can I say greater than? So if I'm looking for a volume example, could I say volume over 10 million shares or something like that?
So,
greater than or equal to 10 million shares, or is it just purely quality testing?
no, I don't believe so because it's a string match. Marcin, feel free to correct me.
I guess so. We should ask Adrian.
Where is Adrian?
Response is equals only.
Okay.
Oh, okay, that's great.
So the answer was you can do equals only.
Okay, the question was, can you do anything greater than or equal to, like let's say if you have volumes, can you do greater than or equal to? The answer is you can only do equals only. Cool. So another thing we're going to look at here, this is the last thing, is I'm going to query Google Alphabet actually. And what you see here is some latency occurred. Now, if I go back to my PCF metrics, I will not see anything in my logs because it was just delays in my response. So what I can do here is go back to my Zipkin, go back to my quotes, do the same drill as before. Okay, US first. Less than a minute ago. Okay, so right off the bat, I see quotes processing. Looks like some events occurred. If I click here, I see, of course, I've put sleep in my code that made it to production, so that's great. So these are just a couple of scenarios. You can think of it in a broader, let's say if you have really specific business use cases that you can really code and query and you can customize using Sleuth Stream or Sleuth and Zipkin. I think it's an amazing tool.
How does it know which particular service the entry came from?
So the question was, how does Zipkin know that a span came from a particular service, right? So when we're doing instrumentation, when we're sending span from the process to Zipkin, we are explicitly telling it that, appending this information to span, that it came from this particular service, because the spans are sent to Zipkin from a particular application. So we know that it's related to that application.
So let me. So you have added the. So Boris, so you have added the Sleuth Stream dependencies into your certain applications, right? And when the Sleuth starts, the traces starts from that certain application, it knows it came from those different the first application, and that's the first starting point.
For example, the property Spring application name.
Yeah, exactly. All right, so that's all I had for my demos. Going back to our slides, and I'm perfectly on time. Yay! Okay, we'll have 10 minutes for questions, which is great. So summarizing what you saw from Marcin and me is log correlation really allows you to match logs to a given trace and span, and you can really customize it. Of course, distributed tracing allows you to debug issues and latency issues as well. And as you saw from both Adrian's talk and our talk, Zipkin is an amazing tool where you can visualize each request and response end to end. And Spring Cloud Sleuth as a tracer really makes our jobs as developers simpler to communicate these applications to Zipkin. And if you're using Pivotal's Cloud Foundry, when you're integrating your applications with Spring Cloud Sleuth and Zipkin, you can deploy Zipkin as an application, and it becomes all of this like ties back together. So these are the links from the resources from both Marcin and my talk, and you can take a picture.
No boss.
All right, so time for questions. So, oh, sorry. Sorry.
Go back,
okay.
go back.
You can ask questions, it's fine.
Okay, so this is kind of not really directly related to this, but I noticed that you're using the search discovery service. And the question is, why, we're wrestling with this, why do we want to use that when we have PCF? Don't they do sort of the same kind of thing? What's the advantage of using the discovery service when we have PCF?
Correct. So, okay. So the question is, why are you using service discovery when you're already using PCF that has a inbuilt router and reverse proxy, right? So we get that question a lot. The reason you will be using service discovery is every time your application wants to communicate with another application, if you're not using service discovery, you will be going back to PCF router and coming back in, right? So the reason you will be using either server-side service discovery or Feign client-side load balancing and service discovery is because you don't want to go out. You don't want to go all the way out to the router and then come back in. You can just be inside the ecosystem and use that.
I thought you had to go out to the router. I thought
No.
one app couldn't talk to another one. When I did tests of that, it wouldn't let me do it. So when I did research to find out why, basically things had to go out to the front door. Maybe that's changed.
So so which version? Yeah, so we have to talk offline. So we have changed that a lot.
Okay.
Yeah. All right.
So more questions?
Yeah, so if you go back into your Zipkin, this is a simple question.
To mine or his?
Yours.
Okay.
I just want to verify. So if I use async, all of that would be parallel, right?
Yes. I mean,
Because I'm using future.
yeah. So it can happen that you already, like I showed you.
The question?
So the question was, if we're using a sync, in this case, if we made it parallel, like all the bars would be one after, like below another. Yes, that's the case. I mean, you could do it like that at some parts are synchronous, right? Then you start asynchronous, and you could have such a situation like I shown that you got the response, but still async is done.
Depends on your use case.
Yeah, it depends on the use case.
Right.
Okay, more questions? No?
If you have like multiple instances of the microservice running on PCF, and there is an issue with only one instance of the service, how does Zipkin help us to isolate that one instance and figure out like, rest all services are working fine, rest all instances, but this one specific instance has some issue?
Okay, so the question was, if we have like a couple of microservices and there's a problem with one,
No.
how we can isolate that? Oh, okay.
So let me ask you this. One instance of a certain microservice?
Yeah.
Okay. So his question is, if we are running PCF, we have issues with particularly one instance of a microservice, how will Zipkin isolate that? It cannot, right? It will not know. Because another thing to think about is, why will one instance of a microservice have a certain error that other instances will not have? Because they are exact replicas of that instance.
But if you had such a situation and you have like 100% of sampling, you will see that every now and then you have a problem with a particular instance, and actually, if you click it, you see the address. So you could find, oh, this is that particular instance that has a problem. So you could find it. Yeah, there you go.
With the advent of reactive programming, how is this specific? Just as an example, you get a request, and anytime it wants to get back support.
Okay.
Everything is totally different when it comes to reactive.
So the question was related to some, let's say, event-related programming, how Zipkin could help. It could help you because, for example, if you check out the Spring Cloud Sleuth docs, there's a link to an application called the Brewery that we use for end-to-end tests, and there is some messaging going on there, so Sleuth helps you with messaging. The problem is that your trace could look disastrously. I mean, like, it would be gigantic, right? Because you're waiting for 25 minutes, for example, for the message to be sent back. So let's say we're working on making something called like linked spans. But let's say for the time being, you would see a gigantic graph. Okay, maybe somebody from this side.
All right,
there are no questions on this side. So okay,
we have 5 minutes left. So.
Does Spring Cloud do any bridging between the data that's in the trace and what actually is in the logs? So for example, if you're logging an event on the tracer, is there any way to get that propagated to the logs?
So the question was whether Sleuth allows you to, like, most likely customize what from the trace is put in the logs. So you can do that because we have a, let's say, span logger interface. The default implementation, if you have SLF4J is the SLF4J span logger, you can extend it, put whatever you want in the MDC. You will have to, of course, change the logging pattern, but you can do it. Wait, Jesus, I don't know, there. Yes, there is an integration with the browser client. You can talk to Adrian afterwards for the details. Yes. I don't remember. Yes?
Yeah.
So the question was if I heard you correctly, because I barely heard you. So if we have a single instance of Zipkin, if it goes down, the question is what's going to happen? So if you have RabbitMQ, you're going to send messages to Rabbit. And once you start Zipkin again, he's going to take those messages. If you have HTTP, it's going to blow. Right? You're going to lose those spans.
So your microservices won't be affected.
Yeah, obviously. Yeah. Very good. So is that a question?
Yeah, I'm scared. if there's rather than just like a 10% of everything, you're actually logging when there's an incident.
Okay. So the question is, maybe let me rephrase it. So if it's possible to turn on like sending to Zipkin for a particular scenario, for example, for a request. So as far as I remember, it's not possible for the request because we take the decision like before the request came. So when you have a sampler, it doesn't know about the request, right? This is the problem. You can do I wouldn't say a hack, let's say custom solution that you could pass it somehow via, for example, thread local. I didn't say that, but yeah, like out of the box in a nice way, like you can't do that. Okay, we have 1 minute.
1 minute.
There you go. Can Sleuth be integrated with Splunk? I mean, Sleuth just gives you log correlation. Let's say it defines a pattern, but what you do with the logs, it's up to you, right? Yeah, of course. There.
Simple question. Can you get top 10 low performance out of it?
Top down.
Top 10.
Yes, of course. So if we go back to Zipkin, so the question is if we can see top 10 like slow performance.
Yes.
Actually, by default, it's searching via longest first, right?
There's no built-in job to rank the top 10 stuff. But like for example, the dependency view is one of those things that's not created. So some people will have multiple jobs.
Can happen. Yeah. Duration. Yep.
Another thing that you get is when you click, you have the longest first, right,
yeah.
from a particular period. So that can be like an answer.
Right. So.
Okay, so this is last question.
Yeah.
So can we set any notifications? I would say that this is not the tool. If you have a KPI, something really important, and you need some alerting, use Coda Hail metrics, send it to Graphite, and do some alerting via, for example, the tool called Siren or any other tool that can do alerting over the Graphite. And then you will like pop up messages to Slack, mails, PagerDuty, whatever. I would say that this is a different tool. OK, thanks a lot.